Okay, in this video we're going to talk about determinants and what information they give us. So let's consider solving this system of two equations. Well, we can see that 2x plus y equals 5 and 2x plus y equals 6. These, if we solve these for y, we get y equals negative 2x plus 5. Here we get y equals negative 2x plus 6. And if we were to graph those, we would end up with parallel lines, yeah? Which they never intersect, which means there's no solution to the system of equations. So notice now if I calculate the determinant of the variable part of this equation, the determinant is 2, 1, 2, 1. And when we calculate this, this is 2 minus 2, we end up with 0. So when we end up with 0, what that's telling us is our system of equations doesn't have there's no solution. Or it could tell us that the system has an infinite amount of solutions, because let's say we had this. Well, now these two graphs are the same thing. They intersect everywhere because they overlap each other. This has an infinite amount of solutions, but the associated matrix here is going to be the same answer. So when the determinant is 0 of the variable part of our system of equations, it tells us that the system either has no solution or an infinite amount of solutions. To illustrate, let's say we change this. This was our problem. Well, now it's different. These two lines, if we solve each equation for y and graph, we're going to get these two equations. They're going to intersect. There's going to be a unique solution. But notice when we calculate the determinant, 2, 1, 2, negative 1, we get minus 2, minus 2. The answer is not 0. And that tells us that there is a solution to this system of equations, because it's not 0. Now if we consider three equations, now let's say our third equation is a multiple of one of these two. Yeah? Let's say it's a multiple of this. 4x plus 2y, I'm multiplying this by 2. So that means when I add negative 2 times this row plus this row, if I just look at the coefficient matrix, 2, 1, 1, actually we'll put this 3, 1, negative 1, and 4, 2, 2. Notice when we try to start solving this using matrices, like I said, the first step is we multiply row 1 by negative 2 and add it to row 3. Well, row 3 is the only row changing, so let me write down the first two rows. So again, when I do this arithmetic, negative 4 and 4 is 0. Negative 2 and 2 is 0, negative 2 and 2 is 0, negative 16 and 16 is 0. So notice when I calculate the determinant of this right here, 2, 1, 1, 3, 1, negative 1, 0, 0, 0, whoops, the determinant of the coefficient matrix, when we calculate this, we're going to get 0 because of these zeros down here. Again, what is that telling us? It's telling us that the system either has an infinite amount of solutions or no solution. In this case, because these two are the same equation, there's an infinite amount of solutions. Now, the last thing is, in 3 dimensions, what is this graph? What is the graph of each of these equations? In 2 dimensions, the graph is we get straight lines. In 3 dimensions, we get planes. The graph of this is a plane, And if we have another plane that's the same thing, they're intersecting everywhere because they're the same plane, and then you might have another plane cutting through this. But there's an infinite amount of solutions. If we had three distinct planes, one here, oh, let's say one was perpendicular and then another one cut through, and they all intersected somewhere, whatever, here and then here. They're all going to intersect at a point, and we get a unique solution. But the point here is, graphically, these graphs are planes, and when we get a unique solution, the solution is the point where the three planes intersect each other.